Welcome to our project for this unit. What we are making is a joystick controlled motor. Uh, so we control the speed and direction just using, in this case, the x-axis of the joystick. That is your objective. It's actually a relatively simple circuit. I mean, it's very similar to the zoetrope in terms of how we control the motor. We just got our chip here. I'll zoom in a little. It's still probably a bit hard to see, but we're powering it normally. I've got the top rails at 5 volts, powered from the Arduino, bottom rails 9 volts from the battery pack. I connected their grounds, which is not a bad idea. And then I'm only connecting to one of my ground pins. So if you look at this black wire here, it goes from the ground of my battery side, which is connected to the ground of my 5 volt side. And then that just goes to one of the middle 4 pins. And so even though there are 4 pins, we're fine just putting one wire there. It makes no difference. Aside from that, powering the internal chip logic with 5 volts. Powering the motors with 9, so I've got to be a little careful. Don't want to leave it on too long or hold it stopped or anything like that, because that's a lot of power for that little motor. Yellow wires go to the A pins. I'm using pins 7 and 8 on the Arduino, connecting to A1. 7 is connected to A1, and pin 8 on the Arduino, digital pin 8, is connected to A2. And I am using this green wire here, goes to my enable. That's going from pin 10 on the Arduino to my enable for this side. I am using analog right to this guy to control the speed. And the way I decide on the speed is based on an analog read from our lovely joystick here. So the joystick's pretty simple. It's basically a potentiometer. But notice we got a ground hookup, which connects to 5 volt ground, which is the same as all ground in this case. We got plus 5 volts, which is connected to plus 5 volts. And then if you look at it, we have VRX. So it's just the x-axis of the joystick. It's again like a potentiometer. So it's like the middle pin of a potentiometer. If you're using a potentiometer because you don't have a joystick, middle pin, just connect that to one of your analog pins. And then I just analog read off this guy, figure out how much I've turned the joystick. By default, it's 512, 513 for me. I hard-coded a dead zone from 505 to 520. That means if I analog read and get 505 to 520 off A0 here, the motor's off. So I have a variable saying, hey, is the motor off? And to decide that, it's checking to see if it's in the dead zone, if it's in the 505 to 520 using analog read. And then I determine in direction based on, hey, is it greater than 512 or less than 512? Remember, analog read goes from 0 to 1023. So if it's greater than 512, if I'm reading off that, it should be going in one direction. If it's less than 512, it should be turning the other. So that's nice and easy to figure out. I have another variable for motor direction, and I have a third variable, motor speed. And with that one, I'm using absolute value and distance from the middle, 512. So I use absolute value of the distance, the difference between the analog read and 512. That gives me distance from the center. And then if you think about it, that's giving me a number between 0 and 512, because it's either 512 above at max or 512 below it at minimum. And we want to convert that into a number between 0 and 255, so we can use it for analog right to control our lovely motor here. To do that, you can use the map function or just divide by 2. And that's how this guy works. Thanks for listening.